Corporate finance practice problem using Excel. Payback period. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we're on the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information on the left-hand side, we're going to populate that information into the blue area on the right-hand side, calculating the payback period, this being one of many type of calculations we might consider when we're thinking about where to put our money for long-term investments into the future. So these are long-term investments we're considering here. We're thinking about something usually that we have to put money down up front for in order to get a return in the future. The payback period is probably one of the first kind of things that will come to mind if you put down a lot of money, and that is, well, when am I at least going to recover the money? So before I start thinking about the time value of money and this kind of thing, maybe I just want to see, when I'm going to get my money back and feel that I'm secure in that point. So this does not take into consideration, it has limitations, of course, doesn't take into consideration profits after that point in time. It's just telling us when we're going to recover our money back, not including time value of money. But it can't really compare then projects that are of different lengths very easily, but it can give you that initial kind of calculation. It's one calculation among many that we would want to put together and look into the future as best we can from these different type of angles in order to make our decision for a decision that's going to affect many periods into the future. So we're going to say the investment is $220,000. We have two things that we could be putting the money into. We're going to say product A, product B. We're assuming we put the money into the product so that we get a return on it in the future. Now, this could be a product, this could be a project, this could be equipment that we're putting money into. The idea being that we're putting money in so that we get a return on it at some point in the future, and it takes an initial investment in order to do that. Then, of course, we would have to predict what the future cash flows would be for the different options that we're putting into place, and then do analysis such as a payback period, such as time value of money calculations, which we'll do in the future to try to decide which project would be the best project to do. So here we're going to estimate, we're going to say that the product A, we're going to get a return in the future in year 1, 70,000, year 2, 40,000, year 3, 60,000, year 4, 70,000. Product B, return 90,000 in year 1, 55 in year 2, 50,000 in year 3, and 40,000 in year 4. So then the question on the payback is, okay, when are we going to get paid back? So the best way to do this, let's start with product A, and I'm going to say the investment, the initial investment, we'll just do a running balance type of calculation. We'll start off with the investment at the 220. And then we're just going to say period 1, and I'm going to say years 2, 3, and 4. I'm going to center these by going to the alignment group and centering them. And then I'm just going to pull over our information in terms of the flows that we expect to be happening each year. We could do this by going to equals the 70,000. I can autofill that on down by putting my cursor on this 70,000 on the fill handle, dragging that fill handle down. We have then our flow. Now we're going to do a running balance, and we're going to take the amount that we invested minus the amount that we're going to get back. Once this column flips to negative, that means that our investment has been recovered, not including time value of money, but just standard dollars have been recovered, and everything beyond there would be profit. So let's go and do that. We're going to say this would be the 220,000 minus the 70,000. 220 minus the 70, we get the 150. Let's do it again. We're going to say this is going to be the 150 minus the 40,000 we're going to get back. That leaves 110,000 not yet recovered. So we still, have investments that we haven't got back with the revenue after year 2. The 110 minus the 60, we still have 50,000 that we have not yet recovered. And then finally the 150 minus the 70 in sometime in year 3 point something, right? We recovered the money and we had extra revenue after that point in time of the 20,000. So obviously when you think about this type of calculation, you can clearly add up the flow that we have here, which is the 240,000, and we could say, well, this is going to be equal to the 240 minus the sum of what we think we're going to get back, and that means we're going to get revenue of the 20,000 after the 4 years. That's our assumption. But then the question with the payback is, well, when are we at least going to get the money back? And that would be another kind of level that we can level up on here to consider what the risk would be for us to put the money down. Obviously, we would like to get our money back sooner. That would make us feel better, make us feel like there's less risk. And that would mean, obviously, if we're comparing two projects that are similar in nature, if we were to get money back, sooner within the 4-year time period, then that might be a more beneficial project. We might feel more comfortable with that one. But in any case, we'll then say, well, now we got this fraction of a year. Well, what's the fraction of a year? So we can calculate the fraction of a year by saying this is the amount that is still remaining after year 3 was 50,000. And then we're going to take the next year cash flow total, which is year 4, where we're going to get the 70,000, and we'll divide those two out. This is going to be the 50 over the 70. And adding some decimals, we're going to go to the numbers group and add a few decimals. We got the 0.71. So this is going to be the partial year calculation. And so we got the payback, which is going to be is going to be equal to the 3 years. It's going to take 3 years plus part of a year, 0.71. Now that 0.71, you could kind of think about that. You could break it down by month, for example. I could say, okay, well, let me go through the months and just to recalculate that 0.71 just to make it make more sense to me. If I break out the year 3 to 4 in months, in days, let's say, let's do it days. You could do it days or months here. I'll say 1 and 2, and there's going to be 360 days. We could say 365, but I'm just going to say 30 times 12, 360, make it even. And then I'm just going to copy this on down for 360 all the way down here. This is obviously something you could do in Excel, much more difficult to do outside of Excel, but pretty easy to do with it in Excel. You can also do it by month as well. So I'm going to bring it down to 360 right there. And then I'm going to basically center this. Let's center this. Let's make this a little bit wider. And then we're going to be I'll pick up the fraction here. So the fraction is going to be equal to this number divided by 360. So divided by 360, and then I'll add a couple decimals here. Let's add a couple decimals, and then I'm just going to copy that all the way down. So this is going to be copied all the way down to, dragging this all the way down to the 360. And there we have it. So we could see down here finally that the last point would be the full 1 year, and then we're going to go back up top, and I'm going to then pick up the amount, which is going to be the 70,000 that we're going to earn, we're assuming evenly, over 360 days divided by 360, and then we'll copy that down. I'll just say this equals the same number, so I want to copy the same number all the way down, copying this down 360. So there we have that, and then we'll pick up the running balance here. The running balance is going to be equal to this number, and then we'll just have the running balance. The running balance needs to get up to 50,000. Once this gets up to 50,000, we should see that fraction of the year matching 0.71 about. So I'm going to take the 194 plus the 194, and let's drag that all the way down for 360. Dragging it all the way down to 360, we should get to the ending number here of the 70,000. So there's the 70,000 total, which is this number, and we're trying to get to 50,000. So when do we get to 50,000 in the year? So if I go all the way down here, we're at the 50,000, which is way down here, right there. So some place between here and here, we got to the 50,000, and that's 0.71% of the year. Or 0.72, between 0.71 and 0.72. And then you could basically, this is the day in the year, so you could figure out which month that would land in, and so on. So if you're in the day 257 divided by 30, we can get to 9 months there. Adding some decimals, we'll go to 8.57 months. So you could break it down in a few different ways if you want to just understand that fraction of a year a little bit better. So that's going to be the 3.71 that we got here is going to be the same as the 0.71, 0.72 that we have in our calculation then up top. And so there we have that. Let's do it again. Let's put an underline here, font group and underline. So now let's do it for project B. So to do that, I'm going to hide project A. I'm going to put my cursor on column E, drag on over to column N, I believe that is, right click and hide. And let's do it again. So our running balance up top, we're just going to say that the investment is going to be this time for, let's put that here, investment is going to be equal to the same 220,000, and then year 1, 2, 3, and 4, going to center those, alignment and center, just picking up our cash flow, 90,000, 55, 50, and 40, putting my cursor on the 90, and then auto-filling on down to pick up the rest of them, and then I'll do the same kind of running balance here. So this is what we have. We need to get it covered by the inflows. So outflow of the 220 minus the 90,000 means we have 130 still not covered. This equals the 130 minus the 55,000, 75 still not covered. This equals the 75,000 minus the 50. We have 25 still not covered. This equals the 25,000 minus the 40. Now we have the 15. Now note here, and you can calculate this down below, this equals the 220 minus the sum of the inflows. That means we have a 15. So you can see the difference in the income there. But we also want to see when are we going to get our money back between the two projects, and that's going to be our calculation. So we have the 15 cash flows over the initial investment. Let's calculate when we get the money. It's going to be somewhere between year 3 and 4 again. Then we could do our partial year calculation looking something like this. It's going to be the 25,000 still needing to be picked up. And then we're going to pick up the next year cash flow. So divided by the next year cash flow, which is the 40,000. And go to the font group, underline that, and that's going to be our partial year. So the partial year then is going to be equal to the 25,000 over the 40,000, making that a decimal, numbers group, decimalizing it. So we've got the 0.63. So that's going to be equal then to the 3 years plus 0.63, or 3.63 years. 3.63 years. If we take, obviously, the amount, we imagine a 365 year, 360 days in a year times the 0.63, that would bring us out to basically day 225. If we take the 225 day and divide that by 30, dividing that by 30, imagine 30 months, 30 days in a month, we get to 8. Going to hit the numbers group, add a couple decimals, we're at the 7.5. So you could think about 7.5 months, day 225. You can also get there, of course, by saying 12 times the 0.65 and then add a couple decimals. We're looking 7.5. If you did the running balance here in terms of the days in the year 3 to 4 here, we could say 1, 2, and then go ahead and add those all the way down to 360 again. Just do this to 360. So there's the 360. And then center those. I'm going to center them. I'm going to make them a little bit larger here. And then we could say that this is going to be then equal to the fraction of a year, which would be 1 over the 360. Imagining 360 days. And then this is going to be equal to the amount of year 4, the 40,000, divided by the 360. And I'm going to take that. That's going to equal the same amount all the way down. And this I'm going to copy down one time here. And then I'll copy this whole thing all the way down. So I'm going to copy this all the way down. All the way down to the 360. There we have that. And so then going back up this column, I'm going to add some decimals. So there we have that. And then we're going to be picking up the running balance, which is going to be this. And then the running balance will be the prior balance plus the current balance. And then if we have our running balance for the 360 days all the way down, assuming that we earn it evenly over the 360 days, there we have it. There's the 40,000 at the end. And we have then, we're looking for this, this to make 20, we have to cover the 25,000. So looking 25,000 on the right, we're looking, when do we get to 25,000? So it's right here. There it is. And there it is. And so that's going to be our 0.63. So at 0.63 there. And so that should tie out to basically our 0.63 that we got there. So I know this might be a little bit over the top to do the partial year calculation, but just note it's useful to be able to make these kind of tables. It could be a little confusing to think about the partial year. When you do this in a book problem, this partial year calculation is usually the thing that kind of throws people off, and they could basically represent that as a fraction. I mean, they could represent it as a decimal. They could represent it in months. They could represent it in days. And just so conceptually, you want to know, what that means, of course. And then in a book problem, you want to be able to convert that to whatever format that the answer will be. Usually, people get pretty good at doing this right here, and then they get tripped up doing this right here. So it's useful to fully understand this calculation, do it a couple different ways, do a running balance by month, do a running balance, by day if you want. Convert it to days, convert it to months and a fraction, month and days, kind of calculation can be useful to then do. So if you compare these two, we got the 3.63 versus, if I unhide, putting my cursor on C to N, CN, or right click, I'm going to unhide those cells, unhide them. And we got the 3.75 versus the 3.63, which is the payback. And we would want to get paid sooner, so the 3.63 would typically be better in that situation. Also note that happens to look better too from a time value of money situation as well, because we get paid sooner here with the 90,000. And that might also, usually that could be the case if you have two projects that are similar in nature, because the payback period will result in you getting paid back sooner. But it's easier, or it's better look to see of those kind of effects by using time value of money calculations, which we'll take a look at in future presentations.